So hello everyone, today we are going to solve the problem first occurrence. So they give two strings txt and pat. So we return the zero based index of the first occurrence of the substring pat and txt. So if pat is not found, return -1. So note, we should not use any inbuilt function. So that's a restriction for us. So for example, txt is equals to geeks for geeks and pat is equals to fr, so the output is -1. So how can we get? So for example, if you see fr is not present as a substring in this geeks for geeks anywhere, so that is why we got the -1. But for is present at here, and the for first letter is f, and f is at 5th index, so output is 5. So if you dry run it, so we are going to use the approach sliding window, which is a approach where we use a window to slide across the given data sequentially to find our required window. So how it works? So we are going to use three components, which is a loop, a variable, and a condition. So for handling a case where the text is of length 1, we use some base case kind of condition. And so this is how the sliding window works. So if you see the text, for example, is geeks for geeks. Let us assume it is a data in the sliding window. Then the window size. Window size depends on the what is the output we are looking for. So we are looking for the pad. So the size of pad is actually equals to the window size. So in this example, what is the pad? It is fr. So length of it is 2. So from this example, if you observe what are the all possible windows we are going to get. So the windows are GE, EE, EK, KS, SF, FO, OR, RG, GE, EE, EK, KS. So GE, EE, EK. So in this way, this is how we get the windows in the sliding window approach, and we check any one of these windows, is it equal to the our required pad window or not, or pad output or not. So any one is not equals to, then whole checking process is complete, so the output is false. But anywhere in between, if it is equal to, so let's suppose it is EE, then we have two EEs, but the first occurrence is here, which in case here we have it is 1, so the output will be 1. The output will be -1 here. So for this, the output will be, for the equal to case, it is 1 for the EE. So this is how the sliding window will be working. So let's see it in practical, in the programming. So we said we are handling a text length where that is 1. So if our text, how we get the length, it is text string name dot length method, is it equal to 1. If it is, then we'll check if directly our pat or txt equals to pat or not. If it is equal to, then output will be true. If it is not equal to, then output will be -1. If it is present, output will be 0. We are giving integers because the return type is integer, and they actually said it, return the first occurrence or -1. So that is where we are giving. So we handle this case. So next, what we use a loop. So simply write a loop for int I is equals to, starting from 0, I less than txt dot length minus pad dot length length. That's it. I plus plus. So for this geeks for geeks example and this first example totally, what are the range of I values we will be getting? 0, so see, we are getting the range of values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we should also getting these values only, because if the window is length 2, So the last window we will be checking is ks. So what is the index of k? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can see we should go up to 11 and this actual logic will be going to 11. So that's how I wrote that. So we'll use a variable which is a string variable and it is a temperature variable, and we get that txt dot substring of I comma I plus pad dot length. So this substring gets the each windows, all possible windows from the given txt data. So we check if the current window is equal to the required pat. If it is equal to, then what is the starting index of the current window? It is I. We simply return I. So after completion of all the loop and every window we checked with the required window, but we didn't find what is the output. It is -1. So simply return -1. So this is how we solve this program. So let's see sample test case. So hidden tests are passed. So now if you check with the sample, so we use a single loop. So the time is big of n. Next, for committing the space, we just use a single variable which takes the constant space. So it is big of 1. So our time is big of n approx and space is big of 1 and the expected of n square. So it is higher than our actual complexity. So this code is more optimized than the expected complexity. So it is the best approach using the popular technique called the sliding window. So learn how this approach or technique is work using this simple here demonstration and practice this program. So thank you for watching.